All right, you guys sent in a fascinating Wikipedia article about the semiconductor industry. Wow, this thing's dense.
It's a big one.
It is, but it's full of really intriguing details. So we are going to do our best to, like, excavate the good stuff, the fascinating facts, see if we can find some surprises in there.
Oh, there's definitely some
Yeah,
surprise.
I bet.
I mean, it's not just silicon and circuits. It's mind-boggling numbers, fascinating history.
Yeah.
Like, this is a global powerhouse we're talking about.
Okay, so let's start with some basics. What is a semiconductor at its core?
Yeah, so the semiconductor industry, it's all about these, like, tiny chips. They're basically, I mean, almost everything these days, right? Your smartphone, your car,
My refrigerator?
probably.
Bingo.
Your refrigerator, yeah. I mean, even, your toothbrush probably has a tiny computer brain in it these days.
It's wild.
Yeah.
So this industry, it's not new, right? Like, it's been around for a minute.
Yeah, you're right. I mean, it really started to take off around 1960. But in just a few decades, it's become like this huge economic force,
Yeah.
right?
Yeah.
Like, think about this. In 2018, the global revenue for semiconductors was over $481 billion.
$481 billion. That's like more than the GDP of some countries?
Oh, it is, absolutely. And get this, by 2027, it's projected to reach $726.73 billion.
Oh, my God.
So we're talking about an industry that's experiencing, like, crazy growth.
Yeah.
And it just goes to show how essential these little tiny chips have become to our, modern world.
It really does. Like, you think about all the ways that technology has exploded in just the past, few years.
Right.
Smartphones, AI, the Internet of Things, all of that requires processing power.
Yeah.
And that processing power comes from these semiconductors.
Exactly. And that actually brings us to another really interesting thing about this industry, which is its, like, global structure.
Okay.
So, semiconductors power devices all over the world, right? But the actual manufacturing is, like, concentrated in just a handful of countries.
Yeah, the article mentioned the U.S., Taiwan, South Korea, Japan, and the Netherlands. What is it about these places? Like, are they just sitting on piles and piles of silicon?
It's not so much about, like, the raw materials. I mean, silicon, it does actually come from sand.
Yeah.
But the real key here is something called a foundry.
A foundry?
Yeah.
No, that sounds interesting. What is a foundry?
Yeah, so imagine a semiconductor foundry, like as a giant, super high-tech printing press.
Okay.
But instead of printing newspapers or magazines, it prints computer chips.
Oh, wow.
Yeah.
So you're saying they're printing these little tiny transistors?
Essentially, yeah. But the thing is, these foundries are unbelievably complex and crazy expensive. Like, we're talking billions with a B of dollars to build and equip just one of these facilities.
So you're saying these foundries are kind of like the gatekeepers of the industry?
Exactly. And the companies that actually operate them, they have a ton of influence.
I bet.
Like, think TSMC in Taiwan, Samsung in South Korea, and Intel here in the U.S.
The big dogs.
Yeah, these are the big players. They're the ones pushing the boundaries of what's possible in chip manufacturing. In fact, TSMC's newest factory, the one that can make those tiny 3-nanometer transistors, cost them $19.5 billion to build.
$19.5 billion. I mean, how do you even conceptualize that amount of money? $19.5 billion. It's mind-boggling.
It is.
It really shows you how much is at stake in this industry.
Oh, absolutely. And it's not even just about, like, building bigger and better factories, right?
Yeah.
There's this constant pressure to innovate,
Right.
to create smaller, faster, more powerful chips.
Which brings us to process nodes, right?
Exactly.
That's something the article mentioned. I got to be honest, that part kind of went over my head.
Okay. Yeah. So essentially, a process node refers to the size of the transistors on a chip.
Okay.
And you can kind of think of transistors like the building blocks of a processor. So the smaller the transistors, the more you can fit onto a single chip,
Oh, okay.
which generally means more processing power and better energy efficiency.
Sure. So smaller is better, basically.
Yeah. In many ways, yes. Back in 1968, the industry was working with process nodes that were 20 micrometers. To give you some context, a human hair is about 75 micrometers wide.
So these transistors were microscopic.
Microscopic, but it gets even crazier because by 2025, they're predicting process nodes of just 2 nanometers.
2 nanometer. Okay, first of all, what is a nanometer?
A nanometer is 1/billionth of a meter.
Oh my God.
These transistors are going to be thousands of times smaller than a human hair.
That's unbelievable. Okay, but it's not all about CPUs, right? Like, the article mentioned all these different types of semiconductors. What's that all about?
You're right. It's a diverse industry. So yeah, CPUs, central processing units, those are like the brains of the computer, right?
Yeah.
But they're just one piece of the puzzle. You also have memory chips, which store data.
Okay.
You have power semiconductors that regulate energy, and then just a whole bunch of other like specialized chips designed for specific tasks.
So it's like a whole ecosystem of chips, each with their own, like, specific job.
Exactly. And some of these areas are seeing insane growth. Like, remember how we talked about how important data storage is in the world today?
Right, right.
So in 2017, memory chips alone made up 30% of the global semiconductor market.
30%? That's huge. What's driving that demand?
I mean, think about it. Everything from smartphones to cloud computing, it all requires massive amounts of data storage, right?
Yeah.
And as we create more and more data, photos, videos, sensor readings from our smart devices, that demand for memory chips is only going to keep increasing.
That's wild. And it makes you think about, like, data privacy and security, too.
Absolutely.
But that's probably a whole other deep dive.
A whole other conversation, yeah.
You mentioned earlier that the raw material for these chips, these really complex pieces of technology, actually just comes from sand. I feel like there's got to be more to the story.
Yeah, so it's a fascinating process going from like this really common material to this, technological marvel. So the sand that they use for semiconductors, it's purified, like to an insane degree.
Okay.
And they create these things called silicon wafers. And these wafers are then sliced incredibly thin, and they're used as the base for building the layers of a semiconductor chip.
So it's not just digging up sand on the beach and, like, sticking it in a computer.
No, definitely not. No, this is where those foundries we talked about earlier, this is where they come in.
Okay.
So they use incredibly precise processes like photolithography to like etch those circuits onto the silicon wafers.
Oh, wow.
Yeah, it's like building a microscopic city on a grain of sand.
It's incredible. It makes you wonder, though, like, with all this talk about, shrinking transistors and pushing the limits, is there a limit to how small we can go? Or are we just going to keep making these chips smaller and smaller forever?
That's the million-dollar question. It's something researchers are trying to figure out right now. As we get closer to the atomic level, the rules of physics start to change. We're entering, like, the quantum realm where things get a little weird.
Quantum mechanics. Okay, now you're just messing with me. But seriously, what does that mean for the future of semiconductors?
It means things are going to get really interesting.
Yeah.
We might hit a wall with our traditional silicon chips.
Right.
But that doesn't mean innovation's going to stop. There's actually a ton of research into new materials like graphene, which could potentially overcome these limitations.
So new materials, new possibilities. Feels like we're on the edge of, like, a whole other technological revolution.
It's entirely possible. And with that comes a whole new set of challenges.
Right, of course. So we're maybe looking at a future where, like, the laws of physics are the biggest thing holding back the semiconductor industry. What does that even look like?
Well, it's a future full of possibilities.
Yeah.
I mean, think about it. As we bump up against these physical limits, it could launch whole new era of material science. Right?
Okay.
Like we might move away from silicon altogether towards completely new materials with properties that, today we can only dream about. Like I mentioned graphene earlier.
Right.
It's incredibly conductive. It's super thin. That's a top contender right now.
It's like we're talking about, like, designing materials at the atomic level to power the next generation of technology. It's like sci-fi.
And it's happening right now.
Yeah.
In labs all around the world, people are working on this. But new materials are only part of the picture. Remember we were talking about quantum computing earlier?
Right.
That's another area that has a potential to completely, revolutionize this entire industry.
Okay, quantum computing. It seems like everybody's talking about it these days, but I gotta be honest, I don't think I totally get it.
I mean, it is a bit of a brain twister. So basically, the way it works is, like, normal computers, they use bits, right?
Yeah, ones and zeros.
Exactly. A bit can be a 0 or 1. But quantum computers, they use something called qubits.
Okay.
And a qubit can be a 0, a 1, or, get this, both at the same time.
Both at the same time. What does that even mean?
Yeah, so that concept, that a qubit can be in two states at once, it's called superposition. And it's one of the really weird and really powerful things about quantum mechanics.
So instead of just on or off, these qubits can be, like, somewhere in between.
Exactly.
That seems incredibly powerful.
It is. Like, incredibly powerful. Quantum computers can solve problems that would take a regular computer, like billions of years to figure out.
Oh, wow.
We're talking about things like drug discovery, new
Well,
materials, breaking encryption. Like, the potential here is huge.
I mean, that sounds amazing, but also like a little scary, to be honest. So where's the semiconductor industry fit into all of this?
Well, you need really specialized hardware to build a quantum computer.
Right.
And guess what? That includes semiconductors.
Ah.
So right now there's this huge race to develop the chips and the technology that will power these quantum machines.
I bet whoever gets there first is going to be in a really powerful position.
Absolutely.
It's like the next space race, but instead of rockets and satellites, it's all about microscopic chips and quantum mechanics.
Yeah. And just like the space race, there are huge geopolitical ramifications here. Remember how we were talking about how concentrated the semiconductor industry is in just a few countries?
Yeah.
Well, as we move into this new era of technology, those dynamics, those power dynamics, they're just going to get more and more intense.
Yeah, that makes sense. Whoever controls this technology is going to have a big advantage, right? Economically, maybe even militarily.
Exactly. And it's not just about like who invents the technology first, but who controls the supply chains, who owns the intellectual property. And then, you've got this whole layer of international collaboration on top of that. It's a complex situation with a lot on the line.
It really does feel like we're not just talking about the future of technology here, but like the future of the world.
Absolutely. I mean, the semiconductor industry, it's really a microcosm of global innovation, competition, and the power of, what humans can do when we put our minds to it. And the story's still being written. Personally, I'm really excited to see what happens next.
Yeah, me too. It seems like we'll be talking about this again soon. This has been quite a deep dive. I mean, we went from the history of semiconductors all the way to quantum computing.
It's amazing what you can learn from like just one Wikipedia article.
I know, right? It's like opening a door to a whole other world.
Exactly. And it shows you there's always more to learn, no matter how much you think you know. So keep asking questions, keep being curious. Who knows what you'll discover?
Well said. And to everyone listening, thanks for joining us on this deep dive into the world of semiconductors. It's been a wild ride.
And remember, this is just the beginning. Keep exploring, keep learning.
And next time you use your phone or your computer, think about the incredible technology that makes it all possible. It all starts with something as simple as a grain of sand, but look what we can do with it. Until next time, happy exploring.